I'm doing this video in two parts because I'm a dork who hit stop when I should have hit play. Okay, so now I've got all my points plotted, and now it looks pretty much like a line, which is awesome because I need to draw a best fit line. It's not perfectly straight, and you can see it's a bit clustered down here, but I'm going to go ahead and draw a best fit line based on what I've got, however messy that is. Okay, your best fit line, I want to make it through, excuse me, I want to make it a visual average. If it touches some dots, that's fine. If it doesn't, that's fine. If it goes through zero, that's fine. If it doesn't go through zero, that's fine. All right, so I've got 10 points, so I need to have about 5 up, 5 down is kind of what I'm looking at. Okay. Something like this. Okay. So there is my best fit line. Now we're really getting to the part where we're getting meaning from this. I ignore the dots from this point in, and I am going to find the slope. Now, if I find the slope by not looking at my data points, I don't care about any of these purple dots, I'm only going to focus on the red line now. I'm going to pick 2 points that are easy to read. You can't see it, but I'm really getting as close as I can to this. Here's one. And if I have to, they could be close together, but I actually would prefer them to be pretty far apart, if I can make it. No. They might have to be close together. I'm going to, this one down here is really, really close. I'm going to take this one right here. Okay, so now I've got 2 points that are mostly dead on. So I'm going to find my slope. We're doing this part now. Calculate the rise over run. So slope is equal to rise over run, which is y2 minus y1, x2 minus x1. Okay, so what are my coordinates here? This one is 0 on the x-axis. Oh, no, I'm sorry. Did that backwards. It is 0.25, because it starts here, and it's 0 on the y. This one, the x-axis is 0.275, and the y-axis is 2.75. Okay, so still doing this, doing the math. So y2 minus y1 is 2.75 minus 0. And we're left with over here, is that right? Okay. Now x2 is 0.275 minus 0.25. Okay, so that's where we're at. Calculator time. Okay, 2.75 minus 0 is 2.75. 0.275 minus point. Oh, that's not 0.25, that's 0.025. Oops, that was a mistake. There we go, 0.025. Okay, remember my scale over here is 0.025, so the first square is only 0.025. Okay, so 2.75 divided by 0.25, yeah, is going to give me what? Hit pause. Okay, back to it, doing some math. 2.75 divided by 0.25 gives me a slope of 11. Now we've got to find some meaning. That's the last thing we're doing. Find the meaning of the slope. Okay. So the question becomes, slope has to have meaning. What is it? So let's take a look. Okay. So this is 11. And I could do my rise over my run for my units as well. My rise is newtons. My run is kilograms. So that means that this is newtons per kilogram. So let's finish this off by thinking about it. We've got newtons per kilogram. It's 11 newtons per kilogram. It is weight, and it is divided by mass. The original question is to determine the relationship between mass and weight. Okay? We come down here, it says mass is a fundamental unit, a measure of the amount of matter. Weight is a gravitational attraction between two objects with mass. Gravity is basically a force. So the difference, all right, mass is here, and mass is in our definition, okay? Mass is in our definition of weight as well. So what's different between these is that weight is the gravitational attraction between two objects of mass. So that tells me that if I'm comparing these two, newtons per kilogram, okay, and I'm dividing it, that relationship should do something with gravity. We ended up with 11 over here, right? All right, what's our number for gravity? It's 9.8. Okay. What do you think? Could this be gravity?